Here's a look at some of the trig functions that can work with the chain rule. These were the ones that were requested by students in the class that get some extra practice with how can you look at a trig function, determine that you need to use the chain rule, and then do a lot of different varieties of the chain rule, looking at the different types that we talked about in class. So I have 3 problems that will hopefully help make things a little bit clearer when you're trying to derive trig functions. The first one you're looking at, the square root of tangent cubed 5x. First thing you want to do when you look at a problem like this is rewrite it. It's not in a very good form because of the radical, and hopefully you're getting more comfortable with that. You have the tangent of 5x, and it's being taken to the 3/2 power because you're going to do power over root. So that's the first thing you want to do. Same type of rewriting that you would have done earlier parts of this chapter. Now when you start to derive this was a type 3 problem. What made type 3 stand out was that it had a trig function to a power that wasn't 1, and it also had an angle that is not just x. And the reason that's important is because you know you need eventually to take the derivative of the angle. That's kind of that innermost layer that we were talking about in class. So when I start the derivative process, I'm going to bring the power out front. Then I'm going to take this original trig function, so the tangent of 5x, to the power 1 less, so you take 3/2 minus 1 to get the 1/2. Think of it just like your general power rule. Power out front, the original thing in parentheses to a power 1 less, and then the derivative of what's inside. Now the derivative of what's inside also has 2 layers. You have to derive the trig function, the tangent. The derivative of tangent is secant squared. And notice that the angle is still 5x. It can't change throughout the problem. And then that final innermost layer is you need to derive the angle. So in this case, my derivative of 5x is 5. Now when you go to simplify this, you're not going to do as much with the trig. You want to double check to make sure you don't have any negative exponents, which we don't here. You want to see if there's any trig functions that repeat, like if you have a tangent and another tangent, which you don't. And then finally, you want to look at your coefficients. So I can multiply 3/2 times 5. I get 15/2. But that's all I can do. And as far as how you write this, you have options. You can either write it in parentheses with the 1/2 out front. You could put the 1/2 right here, if that's more comfortable for you. You don't really need the parentheses that I just wrote. The nice thing about writing it with parentheses in the beginning is you can actually see when I talk about the inner function, you can see in parentheses that's the function that I'm referring to. So here's an example, type 3. It also has a little rewriting to get you comfortable with that technique. The next example you can take a look at here is another trig function. It is another type 3 trig function, but there's a couple things that make this a little different. It is a product rule, so hopefully you're looking at this now and realizing I have a function of x times a function of x. So sometimes it even helps to kind of set them off. This is my function of x. This is my second function of x. So when I'm saying first times the second, you know what I'm referring to. The other thing that I did here, just to not necessarily be rude or mean, I put a pi in there. I don't want pi's to scare you. I'm not trying to be mean. I just want to make sure that when you see a pi, you don't treat it any differently than if you saw the number 3, because it is just a number and I don't want that to be scary. When we start to derive it, we do the first times the derivative of the second. Here's where the chain rule is. Here's where you have to think of all the layers. When you're taking the derivative of cosine cubed, it might help to think of it as the cosine of pi x to the third, just kind of changing the way you see it in your head. You're going to bring the power out front. You're going to take the cosine to a power 1 less, so you're going to drop it down to the second power. You're going to keep the angle as pi x. You're going to take the derivative of cosine, that's the derivative of this inner function, which is negative sine. You're going to keep the angle pi x. And then you have to take the derivative of the angle. You always want to check and see if you can take the derivative of the angle. If the only issue is if it's just x, then it's 1, and you don't have to worry about it. Derivative of the angle is pi, because keep in mind pi is just a number. That's the first part of the product rule. It's kind of messy. We're almost done though. I don't have a lot of room left here, so I'm going to put my plus and kind of put the rest of the product rule down here. What I haven't done yet is the second times the derivative of the first. The derivative of the first is just 6x. All I'm going to do here is I'm going to look at my 2 terms. I know the first one's a lot longer than the second one, but it is just 2 terms, and just see what can I do as far as the coefficient. What I have is I have a 3 times a 3 times a pi, and I also have a negative sign. So 3 times 3 is 9, times the pi, 9 pi. It is going to be negative 9 pi x squared. So that's putting all of my coefficients together in the front. And then I have a cosine squared pi x and a sine pi x. That's my first term, as clean as I can get it. And then my second term, all I'm going to do is put the 6x in front so I don't confuse it as part of the angle of cosine, and write down the rest of what I have. So this is an example of a product rule. and an example of a trig one that is the third level, that third type, where you have a trig function to a different power with a different angle. Biggest thing you want to check when you are deriving trig functions is, did you derive the angle? Did you derive every layer of the problem? I've got one more, and this one, the first derivative isn't too bad. This is actually a type 1 problem from class, because the only thing that makes this a different trig derivative is the angle isn't just x, it's 4x squared plus 5. It is not to a higher power, so I don't have to worry about power out front, power 1 less, because if I did that, power 1 less than 1, it means it's gone. So I am just going to go straight to the derivative, which is the derivative of the tangent, which is secant squared, keeping the angle, 4x squared plus 5, and then the derivative of the angle, which is 8x. Instead of putting it at the end, I'm going to put it at the beginning. Just looks a little bit better. That's the first derivative. Very easy derivative. You only have two levels there. Derivative of trig, derivative of the angle. The second derivative, what makes it harder, a couple reasons. First of all, you should recognize the product rule again. Second thing that makes it harder is the trig derivative is a higher level. It's a different difficulty level because the secant is not to the first power, it's to the second. So we're going to think of this as my first term in my product rule. This is my second factor in my product rule. So the product rule says first times the derivative of the second. Here's where we're doing a chain rule. So it's power out front, because secant is currently squared, so I bring the squared out front. Power 1 less, so now we're down to the first power. The derivative of the trig function, the derivative of secant is secant times tangent, so secant of 4x squared plus 5, tangent of 4x squared plus 5. Again, we're getting pretty long. And then the only thing I haven't done is I never took the derivative of the angle 4x squared plus 5, which is 8x. So this huge piece that you're looking at is all one term. Everything in there can be multiplied together and simplified. We'll do that in a second. Now I need to finish the product rule. So the rest of the product rule is the shortest part. It is just the second, which is the secant squared, 4x squared plus 5, times the derivative of 8x, which is 8, so I'm going to put it in front. Again, all of my energy is going to focus on this big first term and see what can I put together. I have an 8 times a 2 times an 8 way down at the end. So 8 times 2 is 16. 16 times 8. Alright, I don't have a calculator out, so I'm going to go the long way. Show you how I really think about this, that I'm not just grabbing a piece of paper where I've already done it. So 128. And then I have an x here and an x way at the end, so that gives me an x squared. And then everything else that's left is trig. I have two secants. I have a secant times a secant, so I want to write that as secant squared. Then I have one tangent, and actually I'm going to write it and just put a plus sign, and then there is my final answer. So a lot of work had to be done in the beginning because you have that big chain rule, because you have so many different layers in there. You have a lot of things that are all being multiplied together. You just have to make sure you kind of group things together as far as your coefficients, your x's, and then your trig functions. That is about as tough as it can get because you are looking at a second derivative with a trig function that uses a chain rule. And hopefully these problems helped you.